Hello, everyone. Today, let's dive into Section 3 of Chapter 3, which covers the P2P network protocols in blockchain. In a blockchain network, P2P protocols are primarily concerned with the transmission of transaction data and block data between nodes. The P2P protocols for Bitcoin and Ethereum are implemented based on the TCP protocol, while Hyperledger Fabric's P2P protocol is based on the HTTP protocol. Nodes within a blockchain network constantly monitor broadcasted data. When they receive new transactions or blocks from neighboring nodes, they first verify the validity of these transactions and blocks, including checking digital signatures in transactions and proof of work in blocks. Only validated transactions and blocks are processed and forwarded to prevent the spread of invalid data. Next, let's explore the data transfer protocol in Bitcoin. In the Bitcoin network, nodes typically use the TCP protocol, interacting with other peers through port 8333. The types of messages involved in data propagation within the Bitcoin network include version and varic messages for establishing connections, address and gettr messages for address propagation, get blocks, INV, and get data messages for synchronizing block data, and TX messages for sending transactions. Regarding Bitcoin's data validation mechanism, when a node receives data from a neighboring node, its primary task is to verify the validity of that data. Miner nodes collect and validate transaction data that has been broadcast but not yet confirmed in the P2P network. They check the validity of transaction data against predefined criteria, covering aspects such as data structure, syntactic correctness, input and output, and digital signatures, integrating valid transaction data into the current block. Specifically, the data validation checklist mainly includes verifying that the block size is within a valid range, confirming the validity of the block's data structure, ensuring the block contains at least one transaction, validating that there is only one Coinbase transaction in the first transaction, checking the validity of the block header, validating the transactions within the block, specifically examining the following aspects. Ethereum's network communication consists of 3 different protocols, which operate over UDP and TCP. RLPX is used for node discovery and secure transmission, DVP2P for application session establishment, and the Ethereum application level protocol. This table presents the names of various functions of the Ethereum P2P network protocol. For example, ping, whose function is to probe a node to determine if it is online. Pong is a response to the ping command. Find_node, its function is to query a node for another node close to the target node ID. Neighbors is primarily used to respond to the find_node command, sending nodes from the K-bucket closest to the target node ID. Ethereum blockchain validation comes in 2 forms: block header validation and blockchain state validation. Block header validation involves checking a block's parent block hash, block number, timestamp, difficulty, gas limit, and the hash of a valid proof of work. Blockchain state validation includes executing all transactions in sequence, recording the state of each account in a global database, and inserting each state snapshot as a node into the global Merkle-Patricia state tree. Blockchain state validation requires more computation and time than block header validation. Gossip protocol. To ensure the security, reliability, and scalability of the blockchain network, Fabric adopts the Gossip protocol as its P2P network propagation protocol. The Gossip protocol was initially proposed by Alan Demers, Dan Green, and others in a paper published in 1987. The Gossip protocol is a communication method between computers, inspired by the spread of gossip or viruses in human society. The Gossip protocol is also known as anti-entropy. In physics, Entropy represents disorder and chaos, whereas anti-entropy seeks consistency amidst chaos. This vividly reflects the characteristics of the gossip protocol. Within a bounded network, each node randomly communicates with other nodes at level 0. Following this operation, after a series of intertwined and chaotic communications, the states of all nodes eventually converge to consensus. Gossip supports a super-peer network architecture where super-peers have stable network services and computational processing capabilities. They are responsible for maintaining the discovery of new nodes, periodic checks on nodes, removing offline nodes, and updating the node list on the Fabric network. Fabric discovers new blocks, local errors, and missing blocks through broadcast communication with nodes in the node list, updating and maintaining local ledger data. In Fabric, each node encapsulates messages with its own security identifier PKI_ID and encrypted signature before sending a message. Malicious nodes cannot send messages on behalf of other nodes without keys certified by the Fabric Certificate Authority structure, ensuring the security of communication. Alright, we have completed Section 3. Let's summarize what we've learned. The focus of our chapter is that blockchain is built on top of the internet infrastructure, utilizing peer-to-peer, P2P, networks to organize bookkeeping and participation in validation by nodes, enabling the transmission of transactions and blocks between nodes. This chapter first introduced the P2P network and its topology, as well as classic P2P network protocols. Building on this foundation, the chapter further discussed the types of nodes in blockchain P2P networks and the P2P network communication protocols of representative projects such as Bitcoin, Ethereum, and Fabric. Okay, that concludes today's lesson. Thank you.